when we're solving radical equations, it's important to understand something that we've already done when we were solving quadratic equations, or power equations sometimes, or what we call them. The idea is still going to be the same. I still want to isolate my squared term. So in this case, when I go ahead and add that 5 to get it out of there, now at least my squared term is on a side by itself, but I still need to get it alone. And my suggestion here would be, instead of trying to divide by a half, because some of you have some issues with that, is that instead we would multiply by the reciprocal. Because by doing it that way, all that stuff goes away, which is a good thing. And 2 over 1 is really just 2. So 18 times 2 is 36. And now I'm down to my very last part here, where I would take the square root. And again, when we have a quadratic, we get 2 answers, because I start with that squared, and the degree will tell me how many answers there typically are. Now, I'll do the same thing when it comes to b. I'm just going to do it a little bit differently. And what I've seen so far through the quizzes is this is where we have an issue. Here, I can't distribute the squared. I don't want to distribute the squared. That's going to make it harder. So to get the squared off of there so I can get to the x, I'm going to take the square root right away. Because the squared and the square root will get me just left with the stuff that's underneath. I do have to remember, since it was a squared, that it's plus minus. And what's the square root of 4? 2. So then I've just got one step left to get x by itself, and that's to add the 1 over. And here's the last little part where I got to have some caution. Okay, I put the 1 there. The plus minus is kind of my blocker, and I put the 2. Now, is it the worst thing ever if I leave this as my answer? I suppose not. But since there isn't a radical here, I can actually get to the 2 answers. And those 2 answers would be whatever I get when I do 1 plus 2 and when I do 1 minus 2. Okay. And so if there's no radical, that really is a step that we do need to take. But again, that's when we've done power equations before, prior quiz, things like that. So how is that going to apply to what we're going to do today? Well, there's going to be a couple of things that applies to. So let's kind of separate this off a bit. Now we're going to be solving radical equations. Idea is the same. I want to get the radical with the x under it by itself. So, to get the minus 4 out of there, I can add it out. But here's where things change a little bit. Notice there's no squareds anymore, which means there's only one answer. There's not 2. You're like, well, wait a minute. How do I get rid of the square root? Well, up here, I got rid of squared by using the square root. So to get rid of square root, I use squared. Now again, that doesn't mean there's going to be 2 answers. Okay, and 4 squared, 4 times 4 is 16. Now you may notice also that I got this little word over to the right, check. You're like, well, what do you mean? What do you mean check? Sometimes you may get an answer that doesn't work. It's called an extraneous solution. So all I got to do to check is I'm going to take this value, and I'm just going to plug it back into the original equation quick. So just for instance here, so here I'd have the square root of 16 minus 4 equals 0. And a lot of these you'll be able to just do in your head, but if you want to write it out, you could. Square root of 16 is 4, and since 4 minus 4 does equal 0, it checks out. Okay, if that little mini equation wouldn't have checked out, it means I either didn't do something right, or that answer just doesn't work. But again, the big thing to remember here, we're going to kind of make a bubble here. Okay, only one answer for radical equations. They're not quadratics. Especially when we get to the unit test, and you'll have one section where they're like this, where I have two answers, and another section where you're taking square roots. We've really got to be careful of that, because those are little half points we don't necessarily want to lose. It's just something to keep in mind. So then I get to number 2, and I'm like, that don't look nothing like number 1. Well, it kind of does. Okay, I want to get my x by itself. I'm multiplying it by 2. So I divide by 2. Which gets us to our next dilemma. Well, Harty, what do I do? Because that's a half there. Okay, reminder, something to the half power is the same thing as taking its square root. So if you wanted to rewrite this, to look at it that way, you absolutely can. You can do that anytime you see something to the 1/2 power. And now it looks more like number 1 did. I got to get the square root off. I square it, and I can get some big old answers sometimes. Again, 125 squared is not 125 times 2. It's 125 times 125. Oofda. That's a big number. And again, before you circle it, even though most of the time your answers are going to be fine, even if I wanted to go to this step, I really could. Okay, but I'll come back up here. I'll be a good boy. So I'd have 2 times the square root of 15,625 equals 250. And I can plug that into my calculator. Whoops, if I actually get it on the screen. So I punch that in the screen, I punch that in my calculator. The square root of 16,125 is 125. And I find out that 2 times 125 checks out. As long as it checks out, my answer is good. Now again, could you risk it and just say, you know what, I know I did all my work right, I'm just going to start about saying it's the answer. Sure, but then you run the risk of it possibly not working at the end, even if you did all your math work right. It's just something we want to watch out for. All right, 3. First job. Isolate radical. So we're going to minus the 2 out of there first. So that. Now at this point, I can't get to the x term or the 7 because they're both in radical jail still. So if that's the case, I may have to square both sides one step earlier. Just leaves me with the stuff underneath. I'm not going to square the 4x. I'm not going to square the 7. I am going to square the 3, though, because it's not under a radical. And now it's just a regular old algebra 1 equation. I want to get this alone. I'm going to add the 7 and divide by 4. And again, sometimes I can even just do the check. I don't even have to write it out. I won't make you write it out. It's just an idea. But again, here, 4 times 4 is 16. Minus 7 is 9. So the square root of 9 is 3. Plus 2 is 5. That worked. Hot dog. And then we kind of get to the craziest problem of all. You're like, ooh, do I square this whole thing? No. Okay. We can only have one radical per side. So if you get into a situation where you have 2 radicals on the same side as each other, we need to move one to the other side. And typically the easiest one to do that with, if there's one being subtracted, is to go ahead and just add that one, because we like positive values. So once I get here, once I have 1 per side, now I can go ahead and square both sides to get rid of the radicals. There's one more little thing we got to watch out for. It's not on the left side. That's pretty normal. On the right side, that squared not only goes to the square root of x, but it also goes to the 2 out in front. And the important part about that is the 2 doesn't have a radical on it. So this is actually 2 squared, which is 4. But then here, the squared and the square root just cancel. So if there's no radical, if it's not in radical jail, you actually have to do the squaring on that part. And then I could go ahead and get all of my x's to one side. And get to my answer. And that's basically how we're going to do these. Again, one answer per on these is all we're going to be doing. So I got one more I want to do in the more practice section, and then chat a little bit about some of this stuff down below. And then I think, we'll see if my thinking is correct, that we're in good shape here. So, and I might press it. I think I see 2 now that I'm looking at. I think we're going to do 5 and 7. Okay, so 5, a lot like 4 was. First job, add the second radical to get it out of there. And we're not going to be doing number 6, so if you need to take up a little bit of room over there, you can feel free. So once I get that moved, 1 radical per side, we'll square both sides. Left side, they just cancel out. Right side again, be careful. The 3 doesn't have a radical. So 3 squared is 9. But then when it comes to the radical, those 2 guys just cancel. And now it's just going to be a big cleanup job. 9 times 2x is 18x. I'll leave the left side alone for right now. And now I just want to work on getting all of my x's to one side. So me personally, I think it's a better idea to minus the 4x over. So all my x's are together. And then just divide by 14 and get my answer. So it really is, it's a lot of Algebra 1 once we just get that radical out of the way and just making sure that we've got it on one side. So the one other one we're going to take a peek at is number 7. And then we just got some minor things to look at here. Okay, number 7. Isolate our radical, because again, that really just says the square root of x plus 2. So we'll divide by 4, not minus 4. Don't distribute the 4. Okay, we want to isolate it. And if you want, you could even put a square root on it instead, if that makes you feel more comfortable. Because once I get here, now I have to square it next, because that's the only way I can get rid of the radical. And now it just comes down to the little things, like remembering 16 squared is 16 times 16. If in doubt, type it in the calculator. And then just minus my 2 over. And I'm good. Now, just a reminder again, just in case, because I know I'd referenced this a little earlier, but that we didn't run into one where it happened, which I wish I would have done in retrospect. Okay, what is an extraneous solution? That happens if an answer doesn't work when I check it. Now that's assuming I did all my math work right. Okay, if I get an answer wrong because my math work wasn't right, that's not an extraneous solution. That's just an error, and that happens. But if an answer I get after doing my math work right doesn't work, that would be extraneous. Okay? And again, just one more little reminder here at the bottom before we jump into the work today. Questions like this are things I like to have pop up a little more often now, just to get you thinking a bit. What's the first step when solving this? Well, my first step is to get one radical per side. So one way I could say is I'm going to add the square root of 7x minus 4 to both sides. I mean, I suppose you could minus this radical, or you could just say, need one radical on each side. But you've got to be able to explain it in words a little bit like that to kind of reinforce it somewhat. And as far as the bookwork goes, again, you've got a worksheet for this. There's room on the back to at least, I'd say, knock out today's. Tomorrow we maybe need to find some paper. But for today's, you should have enough, and you've got the problems, again, for today and tomorrow on there. So, I mean, if you get on a roll, and you're like, shoot, I can knock a bunch of this out. Tomorrow's assignment's up there already. You can do it with Algebra 2. It's just I'm going to be showing you with the graphing calculator then. So work on those.